Welcome everybody to today's session. This is another security session. Today we'll be talking about general security measures. If you remember when I started last Wednesday, I was talking about some common vulnerabilities like SQL injection, cross-site scripting, and when Timmy came on, he said that those are common vulnerabilities and there are a wide variety of tools to use to prevent those vulnerabilities. And the more critical vulnerabilities that are usually hard to detect using those tools are what we should be focusing on, and those usually come up as a result of business logic flaws. Okay, for example, you write a function and this function is supposed to do this, but we do not check all cases, as in, what if it also does this? Or does it do just this and this alone? Can somebody manipulate it to also do this using the OWASP? OWASP is standard for web web application security, and there are common vulnerabilities that they listed. There's a listing top 10 of vulnerabilities that usually show up in code and according to their level of severity. CI/CD means continuous integration, continuous deployment. So it's written CI slash CD. When developers finish writing their codes, they would have to build, they would have to test, they would have to deploy. So CI/CD uses automation for those processes, that you would just write your code and then you just send it to the CI/CD pipeline. And then based on how you've configured it, it will perform the building, the testing, the deployment. Whenever you push any code, it runs security scans before it is deployed. Okay, so we have different types of tools. There's one called SAST, which is for static application. This is a static application security tool. Then there is DAST, dynamic application security technique. It's used for when you are deploying it or when you've already deployed it. So it can spot vulnerabilities that only show up when you have deployed it, things like configuration settings. Then there's another one called SCA. This is used to check your dependencies to see if you're using any vulnerable dependencies. For the SAS tool, we are using a tool called SemGrep. For the DAS tool, we'll be using GitHub's Dependabot. So I tried running some scans. I configured the Dependabot that would review dependencies. This is the workflow for the pipeline. This pipeline runs on certain actions, like it says on push. When you push it, it should run this pipeline. And when you have a pull request, you should also run this pipeline. The jobs it will do is it will build. It will also check out the code. When it's building, these are the steps it will take. It will check out the code. It will install dependencies. Then it will build projects, and this is the command to build it. Then it will catch dependencies so that it doesn't have to install everything from the beginning on every push. Then this is the tool to perform security analysis. That means after it builds, then it will go to SemGrep that will perform the static analysis of your code to check code. It will run the scan, and we have it in here. Then this is the one for the dependable, the one that checks vulnerabilities. Okay, so this is our GitHub. So okay, this is you come to GitHub Actions to check all your CI workflows. So I have this front end CI workflow, and I've done some push. I was making it to work. So I have one security issue here after configuring Dependabot, and it shows this dependency fast redact, and it shows that it is vulnerable to prototype pollution. So here we can quickly read what it's about. It's a package that provides do very fast object reduction, a prototype solution vulnerability in the nested restore function or fast readout, and allows attackers to inject properties on object dot prototype, just applying a crafted payload, causing denial of service as the minimum consequence. But we can also check the severity scoring. It is low here, 2.9 out of 10. Why? The attack complexity is high. So for somebody to attack this thing, they would have to do a lot. So they may not be willing to try because it take a lot. Then it does not need user interaction. It needs privileges. Yes. So I would do some more settings and configurations that when we have like low severity vulnerabilities like we have here, it could still allow to build or deploy. But for high severity vulnerabilities, in case we have high severity vulnerabilities, the build will not work until you fix the vulnerability. So this ensures that the process is automated, and then it ensures that we are checking for vulnerabilities on the go. We're not just doing security testing after the whole project is complete. There is a place for that where you call an auditor, but then to integrate security from the beginning and from the development, we are on every push, on every change that you make to run the security scan. But based on how you configure it, it could be scheduled like monthly, not monthly, like weekly. But then it's better for every push to check that the code that you're writing is you're writing it securely. It's not giving too much access, so it's not giving room to attacks. This same grep has a UI. I've already written a CI job in my code. So what I needed to do is to push the result here. But it wants me to run the CI job from here to the GitHub code. But I'll fix it. So basically on the dashboard, when it's working, we will see summary of the report. We will see severity and all of that. And the tools would enable you to read. For example, this one has some explanation. It would also have for the SAST and the DAST, I believe. It would also have how to fix it, like quick fix that you can make. It would explain why this is vulnerable to this and how to better write it. So you can just, yes, there are recommended actions to take. So it's easy and it helps us. So I'm not just trying to explain to you what SQL injection is, or you understand it by reading it, and then you can implement the better codes